Hello and welcome to the live session by Infinity Learned by Sri Chaitanya. I am Misbah, your maths educator, and in this session we are going to talk about the basics of lines and angles, that is types of angles and linear pair, complementary angles and supplementary angles. Are you guys able to hear and see me? Hello Kunal, welcome to this session. Are you able to hear and see me, guys? Just confirm that in the chat. So we are over here with the basics of lines and angles on the Infinity Learn class 9 and 10 YouTube channel, and I am Misbah, your maths educator. So let's wait for some more seconds, let other students join as well, and then we'll be starting with the basics of lines and angles. So basically we'll talk about lines, line segments, rays, collinear and non-collinear points, and then adjacent angles and other types of angles. Okay. So let's wait for some more seconds, let other students join as well, Kunal, and then we are going to start with it. Okay, so let's start with it, guys. So the very first thing is a line segment, then you have got a ray, and then you have got a line. Hello Anmol, welcome to this session. So a line segment is somewhat like this, guys, yes or no? It has got a line segment will have two end points, right? A line segment will have two end points. So the length of a line segment is defined. You can find the length of a line segment, right? Because it is having two end points over here. And a line segment is written like this, guys. For example, you've got AB line segment, so you write it like this. You got it? So it has got two end points and therefore its length is defined. So you can write a line segment, you can represent a line segment like this. Now what is the ray? In a ray, you have got one starting point and the end point you don't know. So suppose this is the starting point and then you take any point in between so as to name the ray, right? So the length of a ray is not defined because you don't know where it is going, and therefore we show by this arrow over here. Therefore we represent it by this arrow. And a ray is represented like this. If you have got AB ray, so we write it like this. Is it clear to every student in this session? Now the third thing is a line. So a line basically, it is a ray in both the directions, right? So in order to name a line, you take 2 points lying on the on that line, right? So it is represented by this AB, and you show by 2 rays in both the directions, right? So the length of a line is not defined because it is going in both the directions, so you cannot find its length. In the same manner, length of a ray is not defined. A ray, it has an initial point, Here point A is the initial point and you don't know what is its final point because it is going on indefinitely in one direction. But a line segment, it has got two end points, therefore its length is defined. Is it clear? Any doubt in the basic definitions of line, ray and line segment over here? Just confirm that in the chat, guys. These are the basic definitions which must be clear to you. Okay, very basic things, but it must be clear to you. I hope it is clear, right? Okay. Then you have got collinear and non-collinear points. So you must have heard about these words, right? Co-education, when boys and girls, they study together, right? And then for example, co-workers, people who work together, right? And so basically when you use the thing co, it means you're talking about some things which are working together, which are happening together. So collinear means, for example, you've got a line, or it can be a line segment as well. So suppose A, B and C, they are lying on this line or line segment. So what will I say? That points A, B and C are collinear because they are lying on the same line or line segment. They are lying on the same line and line segment. So therefore points A, B and C will be called collinear points. Is it clear to everybody over here? That is the meaning of collinear points. For example, you have got these points. Suppose something like this, A, B, C. So you see over here, you cannot make a line, you cannot draw a unique line or a unique line segment joining these 3 points. So therefore these 3 points are not collinear, right? These 3 points are not collinear. Now one more thing you have to understand, that 2 points are every time collinear. For example, you take a point like this P and you take a point Q over here. So every time you will be able to draw a line passing through P and Q. Line or a line segment passing through P and Q. So therefore, a pair of points, they are every time collinear, but 3 points will be collinear if a unique line or a line segment can be drawn to joining those 3 points, right? I hope it is clear the meaning of collinear and non-collinear points. Okay. Now you have got angles. What is an angle? You must know that what is an angle. So basically, if I take a ray over here, right? Suppose this is OA, correct? I've got a ray OA and this I'm calling as initial ray. I'm calling initial ray. So if suppose this is an initial ray, something like this, if I'm taking a ray like this and I've got another ray which is moving like that, right? So that ray can be like this, it can be like this, it can be like this, it can be like this. So basically that gap between the two rays, the relative gap between the two rays, that is called an angle. I hope it is clear. So, and this thing, for example, if I show an angle over here like this, so this is called the vertex of the angle, right? This is called the vertex of the angle. Suppose this is, you have already studied about angles, suppose this is 40 degree over here, right? That is the vertex of an angle. Now basically you have to name the angles properly. Suppose this is ABC over here. So this is very important because many students do mistake in these things. Therefore I am telling you, right? So if it is ABC, suppose it's just an alone, it's only a single angle. So I can name this as ABC. If I want, I can name it as angle B. If I want, I can name it as angle CBA as well. And that is equal to 40 degrees. Correct? So this thing is correct. But many a times, if you have got suppose 2 angles like this, if you have got 2 or 3 angles like this, suppose this is A, B, C, D. Now over here you don't know which is angle B. Over here you don't know which is angle B. I have seen many students that what will they do? For this angle they will name it B, for this angle as well they will name it B, for this angle as well they will name it as B. That will be wrong. If at one vertex you are having more than 2 angles, right? More than one angle, if at one vertex you are having more than one angle, so you cannot name it using the vertex, otherwise it will be wrong. Please understand that. So over here 3 angles are there. So for example, if I want to name this angle, suppose this is X, either you take a variable over there, that is correct. So X if I am taking, I have to name it as angle ABD, then it will be correct. Or I have to name it as DBA like this, then it will be correct. Suppose this is angle Y over here, so Y I can name it as angle DBC, or I can name it as angle CBD. So if you use B over here, that will be wrong, this is not correct. If you use B for this angle, that will also be not correct. You cannot use B for any angle over here because it will create confusion. Because at this vertex 3 angles are there, right? In fact, one more angle is there and that is this angle, right? I hope you understand that. But we are talking about these angles only. One angle, the other angle and the other angle. So 3 angles are there, so you cannot name any of the angles as B. That will be wrong. The reason being it will create confusion for the reader. I hope it is clear. So that is a very basic thing in mathematics, but I have seen that many students do mistake in that. Please try to understand that there is a logic behind that as well, that how to name angles. I hope this is clear to every student in this session. Is it clear, Kunal, Anmol, Bimla? Any doubt in this thing? Just confirm that in the chat, guys. Okay, and one more thing. Suppose I've got one ray over here. So I've started with this thing, right? This is the initial ray. Now I'm basically rotating. So it keeps on rotating like this. It can be like this, it can be like this, it can be like this, it can be like this. So you see, this is an angle, this is another 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 angle. What you are doing, you have got a ray and then you are rotating it like this. So it can become one complete revolution. It can take one complete revolution as well. You understand that thing? It can make one complete revolution as well. For example, just understand this logic. if you have got this initial ray over here and the other ray is standing on it as well, the other ray is standing on that ray only, so then this angle will be 0 degree, because there is no relative gap between the two rays. There is no relative gap between the two rays. So that is basically 0 degree over here, right? So we will understand the types of angles over here. So the first is acute angle. So I'll start from the very basic, guys. For example, I have got something like this. I've got this initial ray over here, and if the other ray is also sitting on that, right, there is no relative gap between the two rays, then this will be 0 degree only, correct? And then you started moving the other ray. You just started moving the other ray. So it is like this, it is like this, it is like this. So if the angle is in between 0 degree and 90 degree, then that angle is an acute angle. If it is between 0 degree and 90 degree, then that angle is an acute angle. And if the angle is equal to 90 degree, that is called a right angle. It is like this. The name of 90 degree is right angle. Suppose this is anything, you can take B. So this is a right angle and it is represented by this sign, correct? And if the angle is greater than 90 and less than 180 degree, then that is what? That is called an obtuse angle. No, obviously, Bimla, we are talking, see, basically there is one concept of solid angles as well, Bimla. So that happens in a 3-dimensional plane. But right now we are talking about 2-dimensional plane only. Plane angles we are talking about. Okay, so only 2 rays will be used. I hope it is clear, Bimla. Now, if the angle is greater than 90 and less than 180, something like this, it is greater than 90. See, 90 is somewhere over here and 180 will be somewhere over here, right? So, greater than 90 and less than 180. So, this angle is called an obtuse angle. Greater than 90, less than 180. And the angle equal to 180 degree is 180, it is 180 degree, and that is called a straight angle. Straight angle means you have got this initial ray and the other ray is exactly opposite to it. The other ray is exactly opposite to it. Both the rays are exactly opposite to each of them. So this angle is called a straight angle, and that is equal to 90 degrees, 180 degrees. That is called a straight angle, and this is equal to 180 degrees. Now you have got reflex angle. When an angle is greater than 180 and less than 360, it means, suppose I will show over here to you. Wait. So it means, suppose like this, it is somewhere like this. This is the initial ray. So it has started moving. So see, this was 180, guys. This was 180. So the angle is greater than 180. So the angle is like this. See this thing. It can be like this as well. So it is like this angle. It can be like this as well. Correct? So you can see in this direction as well, like this. So these are these angles are called reflex angles, greater than 180 and less than 360. If it is greater than 180 and less than 360, then that is a reflex angle. I hope it is clear to you. Now basically you will say that why we are doing like this. Suppose it is like this, you can say now that the angle is like this. Yes, that angle can also be said like this. But basically we see in the positive direction with respect to the positive direction. You got that logic? So we understand it like this. When you will move on to higher classes, grade 11, so you will understand, you will see negative angles as well. It's very simple to understand. See, I'll show you. If you have got this initial ray, this is 180, right? And suppose it is somewhat like this. We have got this thing. So suppose this gap is of 40 degrees, okay? This is of 40 degrees, correct? So this total will be what? 360 minus 40, that is 320 degrees or not? Tell me, guys. You know that sum of all the angles around a point is 360. Sum of all the angles around a point is 360. So this angle is, if you see in this direction, so it will be plus 320 degrees, right? But if you see with respect to this, it will be minus 40 degrees. Because when you talk about angles, you are talking with respect to the anti-clockwise direction. This is anti-clockwise. Clock works like this. So you talk about angles in the anti-clockwise direction. That is just a convention. There is no logic for that. So you talk in the anti-clockwise direction. So that you will take as positive. And if you are moving against the clock, then you have to take it to be negative. I hope it is clear. That also I will show, Bimla. That also I will show. I hope it is clear up till here. Okay. Now then you have got complete angle. Complete angle means what? See, the ray was like this. Initial ray it was like this. Then what is happening? The other ray it started revolving. So it revolved and revolved and revolved and revolved, and it has come back to the original ray. So what happens? This complete revolution is making it 360 degrees, right? One complete revolution. So therefore it is called a complete angle. I hope it is clear up till here. Any doubt in the types of angles, guys? Tell me. Okay, I hope this thing is clear. So can you try doing this question? Reflex angle of 110 degrees. Can you find this? Reflex angle of 110 degrees. Try doing this one, guys. Reflex angle of 110 degrees. Yes, correct. It means, see, reflex angle means what? Suppose 110 will be somewhat like this, yes or no? 110 will be somewhat like this. Correct. So reflex angle means this angle, guys, this angle. So whenever you want to find reflex of any angle, for example, it is x, you want to find reflex of angle x. So reflex of any angle will be 360 minus that angle. Correct? 360 minus that angle. So over here, if you are taking x to be 110 degrees, so its reflex angle will be 360 minus 110 degrees, and that will come out to be equal to 250 degrees. So that is the meaning of reflex angles. I hope it is clear. It means you are talking about one angle, and then the angle, when you make one complete revolution, the angle apart from that, it is the reflex angle. I hope it is clear. Yes. So option C is correct. I hope this thing is clear. Now we have got some other types of angles as well. Complementary angles, supplementary angles, explementary angles. So basically the simple logic is, suppose you have got two angles, we are talking about x and y. So if the sum of two angles is 90 degrees, if x plus y is 90, then the two angles are known as complementary angles. Two angles whose sum is 90, they are known as complementary angles. Two angles whose sum is 180 degrees, they are known as supplementary angles. Correct? Two angles whose sum is 180 degrees, they are known as supplementary angles. And two angles whose sum is 360 degrees, they are known as explementary angles. Two angles whose sum is 360 degrees, they are known as explementary angles. Any doubt in that? It is definition. Two angles whose sum is 90 degrees, they are known as complementary angles. Two angles whose sum is 180 degrees, they are known as supplementary angles. And two angles whose sum is 360 degrees, they are known as explementary angles. Is it clear to every student over here? Very basic definition, is it? Thanks, Aditi. I hope it is clear. Any doubt in that? Just confirm that basic logic. You cannot say that I have forgot these definitions, because that will not help you, right? You have to practice many questions so as to remember these things. Two angles whose sum is 90, they are complementary angles. Two angles whose sum is 180, they are supplementary angles. And two angles whose sum is 360, they are known as explementary angles. Okay, now let's do some questions. If an angle is equal to its complement, then you have to find the angle. Can you tell the answer? If an angle is equal to its complement, so you have to find the angle. An angle is equal to its complement, so you have to find the angle over here. Simple question it is. Very good. So Shafi and Kunal is getting D. Exactly. So you see, suppose the angle is x, so its complement will be 90 minus x or not? Tell me. If an angle is x, its complement will be 90 minus x. Now it is given that the angle is equal to its complement. So 90 minus x. Solve this equation. What will you get? 2x is equal to 90. So therefore x will be equal to what? X will be equal to 45. So if an angle is equal to its complement, then the angle is equal to 45 degrees. Very simple question. Any doubt in the question, guys? Tell me. If an angle is equal to its complement, it means that angle is equal to 90 degrees. 45 degrees, sorry. I hope it is clear. A very basic question on the basis of complementary angles. Okay, can you try doing this one? One of the angles of a pair of supplementary angles is 2 degree more than its supplement. 2 degree more than its supplement. So you have to find the angles. Try doing this one. One of the angles of a pair of supplementary angles is 2 degree more than its supplement. So you have to find the angle. See, although the options are given over here, I hope you understand that, Kunal, that I know that from options you can do it very easily. It is very simple. But if it comes as a subjective question, then you have to write the things, right? Maybe if option is not available, so you have to do it actually. So one of the angles is given to be 2 degree more than its supplement. It means, suppose one angle is x, so other is x plus 2 degree, correct? It is given like this. One angle is x and the other angle will be x plus 2, and they are supplementary angles. So what does it mean? That x plus 2 will be what? It means this angle plus this angle will be equal to 180 degrees because they are supplementary angles. So from here, can I say 2x is equal to 178 degrees over here? So therefore the value of x will be what, guys? The value of x will be 2 8s are 16, 2 9s are 18. 89 degrees. So one angle is 89, so x plus 2 will be what? 91. So 89 and 91 is the answer. Any doubt in the question, guys? 89 and 91. Is it clear? Bimla, Aditi, Shafi, Kunal already got the answer. 89 and 91 are the two angles in which one angle is 2 degree more than the other, and they are supplementary as well. You can verify that from the options as well. I mean, this is an MCQ question, so you can easily do from options as well. I hope this is clear. Okay, let's move on to the next thing. Now we have got the other concept of adjacent angles. Okay, this is very important to understand. Try doing it properly. Okay, adjacent angles. Adjacent angles means 2-3 things are there. Okay, if I ask from you, give me some seconds. Give me some seconds, guys. I don't like it if it is not almost perfect. Okay. Can you tell me, if I have got angle x and angle y, are they adjacent angles? Tell me. Are they adjacent angles over here? In the first case, are these angles adjacent? And if I say, suppose this is angle x over here and this is angle y, are these angles adjacent? And if suppose in this case, this is angle x and this total is angle y, are these adjacent? And in the last case, if this is angle x and this is angle y, are they adjacent? Tell me. Which one out of these are representing adjacent angles? This is the first case, this is the second case, this is the third case, and this is the fourth case. In which case out of these options you have got adjacent angles? Tell me. Out of these options, in which case you have got adjacent angles? Can you tell that? Very good. See, over here, these are not adjacent angles. The reason being, because the angles are having only a common vertex. The angles are having only a common vertex. So therefore, these angles are not adjacent. Only having common vertex, they are not adjacent. Now in this case, these angles x and y, they are not having a common vertex. They are having only a common arm. So therefore, these are not adjacent. Angles x and y, they are not having a common vertex because their vertex are different. Vertices are different. You see, but they are having a common arm, still they are not adjacent. Now in this case, angle X and angle Y, they are having a common vertex, they are also having a common arm, but still they are not adjacent. The reason being, the non-common arm, these are the non-common arm, these are the non-common arms, they are lying on the same side of the common arm. You got it? They are having a common vertex over here, they are having a common arm over here, but the non-common arms over here, they are lying on the same side of the common arm. So therefore X and Y, they are not adjacent angles in this case. Only in the last one angle X and Y they are adjacent, because first thing, they are having a common vertex. This is the first case, first situation. They are having a common vertex. Second, they are having a common arm. This is the second thing. Third thing is, the common arm lies in between non-common arms. These are non-common arms, right? The common arm is lying in between non-common arms. You got it? So three things must be satisfied for two angles to be adjacent. Three things must be satisfied for two angles to be adjacent. First is, they must have a common vertex. Second is, they must have a common arm. And the third one is, the common arm must lie in between non-common arms. Or you can say, the non-common arms must lie on the opposite sides of the common arm. Is it clear? So that is the meaning of adjacent angles. Is it clear, Bimla? That is just a definition, no logic is there. Adjacent means things which are side by side. So if you take in this case, these are not angles side by side. Only common vertex will not make them adjacent angles. In this case, they are not having common vertex, they are having a common arm, so only common arm will not make them adjacent angles. In this case, they are having the common vertex, they are having a common arm, but the non-common arms, they are lying on the same side of the common arm. So still they are not adjacent angles. Only in the last one, these angles are adjacent angles. The reason being, they are having the common vertex, they are having a common arm, and the non-common arm, they are lying on the opposite sides of the common arm. So then they will be adjacent angles. I hope it is clear. It is there in grade 7, guys. It is there in grade 7, grade 8, grade 9. I hope it is clear to every student. Now you have got linear pair. What do you mean by linear pair? See. So linear pair means like this. I'll explain that what is the definition of a linear pair. So suppose this angle is X and this is Y. And suppose this is AB over here, or you may call it AOB or C. So over here, angles X and Y are forming a linear pair when X and Y are adjacent angles. X and Y are adjacent angles. We have understood the definition of adjacent angles. So X and Y are adjacent angles, and the non-common arms OA and OB, they are opposite rays. So linear pair means a pair of angles which are adjacent angles, and the non-common arms, they form adjacent rays. I hope it is clear. Or you can understand like this, that if you have got a straight line, you have got a straight line over here, you drop a ray on that, so these angles will be adjacent angle, linear pair. They are forming a linear pair. Suppose in this case P and Q. So they are forming a linear pair. Is it clear to every student over here? Now sum of angles in a linear pair is 180 degrees. Sum of angles in a linear pair will be supplementary. If a ray stands on a line, then the adjacent angles so formed are supplementary and its converse. It means the first case you have to see that if you have got a straight line over here and you make a ray on that, suppose these are angles X and Y, if it is given that this is a straight line, again I am saying, if it is given that this is a straight line and you are making a ray on that, on a point of it, so the angles so formed, they are forming a linear pair. We have studied in the previous slide itself, they are forming a linear pair, and the sum of the angles in a linear pair will be 180. Now you will ask, what is the proof of it? There is no mathematical proof of this. This is an axiom. This is called linear pair axiom. So there is no mathematical proof of that. You cannot prove that why the sum of the angles in a linear pair is 180 degrees. It is it is an axiom. You can practically justify that, but you cannot mathematically prove it like a theorem, because that is not a theorem. I hope it is clear. So the sum of the angles in a linear pair is 180 degrees. That is the linear pair axiom. And its opposite is also true. It means if a ray stands on a line, then the adjacent angles so formed are supplementary and its converse. Its converse will be what? If you have got, suppose you have got two angles, if you have got, the figure is like this, and if you have got a ray is like this, okay? And suppose it is given over here two angles P and Q. So if it is given that angle P plus Q is 180, if P plus Q is given to be 180, then you can conclude that, over here, suppose I am writing AOB, then you can conclude that AOB is a straight line. AOB is a straight line. I hope it is clear. Then you can conclude that AOB is a straight line. So in both ways it is true. If you have got a straight line and you make a ray on that, then sum of the angles formed over here will be 180 degrees. Linear pair axiom, you cannot prove it, there is no mathematical proof to it, it is an axiom. And the opposite of it is also true. If you have got situation like this, it is not given that this is a straight line. Understand that there is a ray, basically three rays are there. If it is given that P plus Q that is equal to 180, so you can say that AOB is a straight line, or you can say that OA and OB, they are opposite rays. They are opposite rays. I hope this thing is clear to every student over here. Any doubt in that to any student, guys? Just confirm that in the chat. So there is no proof to it, because it is linear pair axiom. Don't try to prove it mathematically. You will not be able to do that. But yeah, practically you can justify that. You cannot prove it, although. I hope it is clear. Now you have got vertically opposite angles. This you can prove. This you can prove on the basis of the linear pair axiom. It is given that if two lines intersect, then the vertically opposite angles are equal. It means if you have got two straight lines like this, it is already given that these are two straight lines, right? Suppose it is like this. Two straight lines, suppose L1 and L2, it is given that, right? These are two straight lines over here. And suppose I am taking these to be W, X, Y, Z. Correct? It is already given that these are two straight lines. So you see, if I take L2 to be a straight line, it is given already there in the question. So can I not say that W plus X will be equal to 180 degrees? Because we have studied right now that some of the angles formed in a linear pair will be 180 degrees. In the same manner, L1 is also a straight line. So can I not say that X plus Y is also 180 degrees? X plus Y is also equal to 180 degrees. Can I say that over here? Linear pair axiom. So you see, W plus X and X plus Y, they both are equal to 180. So from here, can I not conclude that W plus X is equal to, I can conclude over here that W plus X will be equal to X plus Y. Can I say that? So I can cancel out X over here. So will I get W is equal to Y, guys? Tell me. So I've got W is equal to Y. So have I proved that vertically opposite angles are equal? These are vertically opposite angles over here, and we have proved them to be equal using the linear pair axiom. In the same manner, see, we have already seen that W plus X will be equal to 180 degrees, the linear pair axiom over here, correct? Because it is already given that L2 and L1, they are straight lines. Now again we can say that L1 is a straight line, so can I not say that W plus Z will also be 180? We can also say that W plus Z will also be 180 over here, correct? So from here, can I not say, if I combine these two results over here, so can I not say that W plus X is equal to W plus Z over here? So I can cancel out W and W. So can I not say that X is coming out to be equal to Z? So have we proved that W is equal to Y and X is equal to Z? So have we proved that both the pairs of vertically opposite angles, when a pair of straight lines intersect, they are equal? I hope it is clear. This is a theorem. This is not an axiom, but the previous statement, that was an axiom. You cannot prove it. I hope it is clear. Any doubt to any student in this session? Just confirm that in the chat. Shafi, Kunal, Bimla, is it clear to everybody in this session? Okay, Bimla, no problem. I'll once again explain the meaning of adjacent angle. See, Bimla, over here, if I make the figure like this, wait, you'll understand it properly. See, Bimla, see, if I make this angle x and this angle y, these are adjacent angles. Why they are adjacent angles? Because the vertex is common, vertex is same. This is the vertex or not? For angle x and for angle y, this is vertex. First situation. Second thing, there is a common arm. Got it? There is a common arm. Second thing, one more thing. The common arm over here is in between non-common arms. This and this, they are non-common arms or not of angles x and y. So the common arm is in between of non-common arms. So then only you can say that x and y are adjacent angles. Is it clear now, Bimla? I hope it is clear. Now in this case, what is happening, Bimla? See, over here, angles x and y, they are having only a common vertex. No common arm is there, because these are the arms of x, these are the arms of y. So therefore, they are not adjacent angles. Correct? What is happening in this situation, Bimla? They are not having the common vertex. They are not having the common vertex. Only a common arm is there. So they are not adjacent angles. For adjacent angles, three things must satisfy. Now what is happening in this one? They are having a common vertex. I am talking about this angle and this total angle. They are having common vertex. They are having a common arm. But these are non-common arms, but they are on the same side of the common arm. So therefore, over here, angle x and angle y, they are not adjacent angles. Only in this case, they are adjacent angles, because three things are getting satisfied. Common arm is there, common vertex is there, common arm is there, and the non-common arms, these are non-common arms. They are on the opposite sides of the common arm, or you can say the common arm is in between the non-common arms. So three things must satisfy for two angles to be adjacent angles. Is it clear now, Bimla? Confirm that in the chat. Okay, very good. Now let's do some simple questions. You know, the topic is very simple, but these are the basics. Therefore, I thought to take these things because these are very important. Try doing this one and let me know the answer over here, guys. It is given in this figure that twice of x is 30 less than y. Twice of x is 30 less than y, then the values of x and y are respectively what? Over here. Try doing this one. And it is also given, don't forget that OB and OA are opposite rays. OB, OA, they are opposite rays. So I'll tell you, it means it is given that AOB is a straight line. If it is written over here that OA and OB, they are opposite rays, it means AB is a straight line, AOB is a straight line. That is what is meant by the statement over there. Try doing this one. Okay, so it is given that twice of x, read this statement, twice of x is 30 less than y. So twice of x is equal to 30 less than y. So y minus 30. This is the first equation or not? Twice of x is equal to 30 less than y. Now the other equation will be, these angles are forming a linear pair. X and y, they are forming a linear pair. So we can say over here that x plus y is equal to 180 degrees because the sum of the angles in a linear pair is 180 degrees, correct? So basically, from here, can I write y is equal to 2x plus 30, guys? Tell me. If I take it on the other side, so y is equal to 2x plus 30, I can put. So let's write over here in place of y, we can write 2x plus 30, and that is coming out to be equal to 180 degrees over here. I mean, even if I'm not writing degrees, you understand that it is they are in degrees only. So over here you'll get 3x is equal to 150. So therefore x will come out to be equal to 3 5s are 15. So this is coming out to be 50 over here. X is coming out to be 50, and y we have got to be equal to 2x plus 30. So 2 into 50 plus 30. So y will come out to be equal to 130. So therefore the angles over here, they are x is equal to 50 and y is equal to 130. So 50 and 130 is the answer. Option B is correct, Kunal. Is it clear to every student in this session? So you have got a pair of linear equations in two variables to find the values of x and y. Is it clear? Any doubt in that? Bimla, Kunal, Jill, Zone? Any doubt in that question, guys? Okay. I hope that is clear to every student. Let's move on to the next question. Can you try doing this one and let me know the answer over here? So in this figure, AB and CD are two straight lines. AB and CD, they are two straight lines intersecting at point O. OP is the ray. What is the measure of AOD? We have to find the value of AOD over here. Correct? Try doing this one. You can just see and tell the answer over here. It's a very simple question. What is the answer over here, guys? Yes, very good. This is very simple because it is given that AB is also a straight line. So these things are given just to confuse you, right? AB is a straight line is already given. So this is a straight line. So what does it mean? Can I not say over here that angle AOD plus angle BOD, that will be equal to 180 degrees because they are forming a linear pair over here, right? So AOD, BOD, their sum will be 180 degrees. They are forming a linear pair over here. So therefore angle AOD and BOD is 40 over here, that is equal to 180 degrees over here. So from here if you solve, you will get angle AOD to be equal to 140 degrees. I hope this is clear. So therefore 140 degrees is the answer. It's a very simple question. Yes, Habib. I hope this is clear to every student. Can you try doing this one? Angles x and y forms a linear pair and x plus 2y is 30. So can you find the value of y? It's a simple question again. Try doing this one and let me know the answer in the chat. So x and y, they are forming a linear pair. What does it mean? That I can write x plus y to be equal to 180 degrees, correct? Suppose this is the first equation because they are forming a linear pair. So therefore x plus y will be equal to 180 degrees. Hello master, welcome to the session. Now it is also given in the question itself that x plus 2y, that is equal to 30 degrees. X plus 2y is 30 degrees. This is the second equation. Now I have to find the value of y over here. So you see, can I think of eliminating the variable x over here? Can I think of eliminating the variable x because the coefficient of x is same in both the cases? So can I subtract the first equation from the second equation easily? I can subtract the first equation from the second equation easily over here. Okay, give me some seconds. You have to find the value of y, right? I think there is some mistake in the values in the question because y is coming out to be negative over here actually. Angles x and y forms a linear pair and x plus 2y is equal to 30 degrees, right? So you have to find the value of y over here. That's what I'm saying. That's what I'm saying. Hello master. So we are not talking about negative values, right? Okay, so still you can do that thing, equation 2 minus equation 1 I am doing, right? So what will happen over here? X plus 2y minus x minus y. So that will come out to be equal to what? 30 minus 180, correct? 30 minus 180 over here. So basically x will get cancelled out. So therefore y is coming out to be equal to minus 150 degrees. Correct? Minus 150 degrees over here. You got that logic? Yes. So basically that would be the answer over here, right? But we are not talking about negative values over here up till grade 9. So let's not get confused in that. I hope it is clear, right? Why 70 degrees Gill zone? See, they are forming a linear pair. X and y, they are forming a linear pair. So it is simple that x plus y, that will be equal to 180. And it is also given that x plus 2y is equal to 30 over here, correct? So you have to find the value of y. So you just can simplify it. You'll get y is equal to minus 150. Is it clear? I'm doing good, master. How have you got, yes Kunal, you are getting, how have you got option C over here, Kunal? I hope it is clear. Are you doing that 360 minus 150, something like that? Are you doing that, Kunal? Are you doing that, Kunal, that if it is minus 150, so I will do 360 minus that? I mean, are you getting that reflex part of that? But I mean, see, that is not making any logic in grade 10. That's what I'm saying. No, question is okay only, but the values are like that. I hope it is okay. The values are like that only, it is not very tough. That's what I'm saying, Swap. It's a simple question only. The values will be like that, okay? I hope it is clear, but the concept is clear to you, right? Let's move on to the next thing. Okay, so this is a proof-based question. I'm giving this as an homework and I'll take it in the next session. I'll explain this in the next session in the class. Okay, this is a very standard question you'll get everywhere. Bimla, if you whatever you may do, you'll get the same answer. Now, this is pair of linear equations in two variables. You're talking about subtracting the second equation from the first equation, then also you'll get the same answer. You can try doing that, Bimla. You can do the same thing, you'll get the same answer. You can subtract the first equation from the second by first. By whatever method you will use, you'll get the same values of x and y. You got that logic? Maybe you haven't studied these methods, I mean to solve a pair of linear equations in two variables, that is there in grade 10, Bimla. But you'll get the same answer, whatever may be the method you will use. X and y form a linear pair, so x plus y is 180 and this is given. So if you subtract over here, you have to find the value of y, right? So y will be equal to minus 150. I hope it is clear to you, right? Now this question is a very standard question. Try doing it on your own. We'll take it in the next session and we'll do that, right? So that's all we needed to do in this session, guys, on the Infinity Learn class 9 and 10 YouTube channel. We are doing Pratham series for grade 9 students and Pioneer series for grade 10 students. Don't forget to like, share and subscribe to the Infinity Learn class 9 and 10 YouTube channel. And also don't forget to subscribe to the Telegram channel so as to get updates regarding sessions and then questions and the PDFs of these sessions. So that's all we needed to do in this session, guys. We'll meet in the next class. Bye-bye and take care, everybody.